Hello and welcome back. We'll be looking at section 6.5 in this video, which is all about how to look at data and tell if we're looking at a normal distribution. And there are a few techniques that we can use, and there are more advanced techniques than the ones that will be mentioned in this video and in this class. But for starters, data that are normally distributed should be bell-shaped. So if we draw a histogram, we should notice that around the mean, we should have lots of values, and as we get further and further away, we should have fewer and fewer values. So it should have that rough bell shape, and it should be symmetrical. And we've seen lots of pictures of these before. So this is something that if you can look at something and see that it's bell-shaped, okay, we're going to imagine that it's going to be fairly normally distributed, or at least pretty close. One other thing that we can do just by really looking is just trying to find outliers. And a normal distribution should not have outliers, or at least not very many. And in fact, if there's more than one outlier, this usually indicates that we're not looking at a normal distribution. So if there are 0 outliers, good. If there's 1 outliers, maybe we just got really unlucky. If there's 2 or more outliers, generally this means this wasn't normally distributed to begin with. And the last more precise way of looking at whether or not data will be normally distributed is to construct what's called the normal quantile plot. And we'll construct this plot, this graph, and it should have a very particular flavor. It must be a straight line, and we'll look at some examples in a second, but it'll have to be a straight line without any patterns popping up in here. So let's define what a normal quantile plot is. And a normal quantile plot, roughly speaking, is a plot of the data values versus their z-scores. And so I should be a little bit more specific. So this is going to be a scatter plot. So we imagine that we've got a bunch of points, and each point xy, so along the x-axis, this is going to be the data value itself. And then along the y-axis, the height is going to be the expected z-score of x. So in a normal distribution, we expect there to be a straight line here, because the data values and the z-scores should correspond exactly to one another. However, in a non-normal distribution, we might get something that looks like this. And while this looks pretty straight, if we actually draw a straight line, we'll see that, oh, there's a wave to this. And this is why I have to mention this second part here. It should be a straight line. Well, this is pretty straight. So could it be a normal distribution? Well, no. The big important detail here is that there should be no other systematic patterns. So having this wave in there will indicate that this is not a normal distribution. So let's look at a couple of these normal quantile plots. I may have to move myself to the other side of the screen. So here is a plot where we have our histogram of, so in this case this will be IQ scores, and how often they occurred in a pretty large sample. So we can see that this has a rough bell shape to it. And when we come over here and we look at this plot, this is going to be the normal quantile plot. And what has been plotted is the IQs, the x values, versus their expected z-score. And what we see is that we get a roughly straight line. There's a little bit of a wiggle to it, but it's not in any noticeable pattern. It looks just kind of random. Maybe there's a couple of people that were getting high scores, but they're not quite outliers. They're not super far away. So this is what we would expect for the normal quantile plot to look like of a normal distribution. It's a straight line without any recognizable patterns arising in there. So what happens if we look at things that are not normal? I'll move back to my side of the screen. In a uniform distribution, where all data values are equally likely, we will get this systematic wave in here. And we can see that it is pretty close to being a straight line, but this wave in here, this very regular pattern, means that this is not normally distributed. A uniform distribution means all data values are equally likely. And a normal distribution, we should see that data values close to the mean are more likely than those that are far away from the mean. So this wave in here will indicate that the distribution is not normal. And then the last one that we'll look at is more of a skewed distribution. So here, this looks like monthly rainfall in inches, and Monday rainfall in inches, and then on all the Mondays, how often did that amount of rain occur? Well, it looks like most Mondays there's very little rain, and some Mondays there was a lot. So what we notice from the histogram is this doesn't look like normal distribution. Furthermore, it looks like there's a couple of outliers way out here. So we can tell that this is not a normal distribution by looking at the picture, in the same way that we could for the uniform distribution. However, maybe we want to be extra sure, so we plot the normal quantile graph. And the normal quantile graph is not a straight line. And in fact, we've got a fairly straight line going up over here, and then another pretty straight line coming across, but they don't make one big straight line. This has a pretty big curve to it. And this is what it'll look like for this skewed distribution like this. We'll have a sort of bent graph here. So in the next video, I will construct one of these plots more explicitly, but I think the main thing here is to just recognize when our plot's going to correspond to, when our normal quantile plot's going to correspond to normal distributions. When it's a straight line without any systematic pattern.